Okay, guys. So, again, welcome to today's live stream. So, in this live stream session, we are going to talk about the geometry modula from our Think Academy AMC 8 book. Okay, so let's take a quick look of the first question. This is a real problem from the 2014 AMC 8 exam, and the problem says a cube with 3-inch edges is to construct it from 27 smaller cubes. Each has a 1-inch edge. Okay. And 21 of these cubes are colored red and 6 are colored white. If the 3-inch cube is constructed to have the smallest possible white surface area, so let me grab my pen and mark those key information. Now, we are looking for 21 of the cubes that are colored red and 6 are white, okay? And among these cubes, our task is to find the smallest possible white surface area showing. So the question is, what fraction of the surface area is white? So for any geometry-related problem, before we start, let's first draw the figure, okay? In this case, we'll need to draw the large cube, okay? So this is my pen. Good. Okay, so since it's a 27 cube constructed big cube, we should draw it by layer. So by referring to the word layer, I actually mean that, okay, so let me draw it better. So it's like this. Okay, so. Now we have 3 layers, and each layer should have exactly 9 small cubes. And our task is to find the smallest possible white surfaces. So let's think about our first step should be count the number of cubes that has 0 surface showing, right? Count the number of cubes with exactly 0 face showing. Okay, think about that. When we only put the cube into the exact middle of our big cube, we'll have 0 face showing, right? So let me draw another figure here. I will use a different color for green. Okay, so in the right middle, okay, this is our cube that has 0 faces showing, because on top of it is another cube, and there is another cube on the left and right hand side, and front and back, they are always cubes. So in this case, that is the cube that has exactly 0 faces. And how many cubes satisfy this condition? Only 1, okay? So there is 1 cube. There's 1 such cube. Okay, now after counting the number of cubes with 0 faces showing, automatically we should move to the number of cubes that has only 1 face showing, right? So what are those cubes? Let me switch back to blue. Okay. Let me check. Okay, good. Okay, so for blue, I will write, let's count the number of cubes with only 1 face showing to the outside, okay? Showing to the audience. Exactly, only 1 face showing. So which are these cubes? First, let me use another color. I will use yellow. So this cube, the yellow one, this should have exactly 1 face showing. Because think about that. On top of this cube, there's another cube. And same as under that cube. On the left and right side of the cube, there's another cube. And on the back of that cube, there's another cube. So the only face that cannot be covered by the other cube is the face that's showing to the outside, right? So that satisfies the condition with 1 face showing out. So this is our first. And similarly, this is our second. There's another one at the bottom. Okay, and here we should have another one. And notice that, well, if you rotate the cube a little bit, in front of and backward, there should be another 2. So in total, there is, so I'm showing 4 here, and there is 2, like 1 is here and 1 is on the back, okay? So in total, there should be 6, right? So let me go back to blue color. I will say there are 6 such cubes. Okay, this is not a blue color I want. This is green. So, okay, now there are 6 such cubes, right? So among these 6 cubes, we are not going to use all of them. Why? Because in total, we are having only 6 cube colored white. And we have already one used for the exact middle one, right? That one has 0 faces showing. So 6 minus 1, which means we just need 5 cubes to complete our task. So in this case, the question is, what fraction of surface area is white? There are 6 such cubes, but we only use 5 of them. Okay? Now, think about when we want to calculate a fraction, we work on the denominator first. For the denominator, the total face. So, as I said, there are 6 faces of the cube. So that is 6 times. And on each face, there is 9 small faces. So 6 times 9, we should have in total 54 faces. And among these 54 faces, one of them has no face showing off, and 5 of them have only one face showing out. So that should be 5 fraction line 54, right? So I will say white faces is 0 plus 5 by our first and second step, which is 5. So the answer is 5 over 54. Okay, now take a look at our options given. A, B, C, D, E. Which one is 5 over 54? That is A. Okay, so this is the problem and how to solve it. Now, we are ready to go to our second one. Second one is an exit ticket, so it's supposed to be challenging, but we can definitely tackle it. It says a cube of 4 times 4 times 4 is shown in the figure below. The rows and columns of small cubes are indicated with shading areas. That has to be removed from our figure. Okay, so let me highlight the keywords for you guys. The rows and columns, which are indicated with shading, have been removed. And a question is, let's calculate the volume of the large cube. So you can see there are 4 figures. Each has 16 smaller squares given to us. Let's try to use them. So the first step is, instead of consider this entire solid figure as one unit, we want to break it down into layers, okay? So this is our first layer. This is our second layer. This is our third layer. And this one will be our fourth and last layer. Okay, so again, this number marks the layers. Okay, now for each layer, let's consider about how many cubes are removed. So for the first layer, it's easy, right? Exactly, these 2 cubes are gone because these are shaded, and shaded cubes have been removed from our solid figure. Now, jump to our second layer. Because you can see in the actual figure, this is a cube, and this is another cube. So this is our second layer, and there should be how many? In the middle, 8 cubes has been removed, okay? So let me draw the shaded part. Okay, so these shaded part are removed from our second layer. So that's in total how many? 8 cubes being removed. Now consider about the third layer. So third layer, you can see on the top, there is 2. So it means there are like 2 columns of cube are gone. And if you consider about horizontally, there is another one, okay? So it should looks like a cross for our third layer. That is exactly in this shape. Okay, looks like a cross. So these shaded parts are gone for our third layer, and for our last and final layer, which one's gone? You can see if you take it on a side view, there is no shaded part. However, think about, okay, horizontally, there is 2 cubes that gives you like 2 rows snatched into our figure. So it should look exactly the same as our first layer. That is, these 2 shaded parts are gone. So the rest part should be easy, right? We just counted the number of unshaded part, which can be found as the total area minus the shaded area. And we know each of them has an edge of 1, so that should just be the final answer. In our first layer, we have 2 gone from the 16. So we are left with 16 minus 2, which is 14. Okay. Our second layer, 8 cubes are gone from a total of 16. So 16 minus 8, which is 8. And our third layer, how many are gone? So in the middle part, there are 8. And on each side, the left-hand side and the right-hand side, 2 of the cubes are gone. So that's 10, right? 16 minus 10, we get 6. And finally, for our fourth and last layer, it should be exactly the same case as our first layer. That is, 2 out of the 16 figures are gone. So we are left with 14 cubes. And the last job is to add them all together. Okay, so let me change the color. We will have 14 plus 8 plus 6 plus 14 again. That is, so that's 2 times 14, which is 28, plus 6 plus 8 is another 14. So it's actually 3 times 14, which is 42. Okay, I will put a little box around 42 to denote that as our final answer. And that's why we choose option B. Okay, very good. So let's do a quick recap about how to solve a problem like this. So when you are given a solid figure, a three-dimensional figure, okay, it may be too complicated if you think it as a unit, as a whole. We want to break it down into layers. Think about what happens in each of the layers. And when you count the number of cubes that are removed from each layer, do not only count the horizontal direction or the vertical direction. Try to think about the horizontal first or vertical first, then think about the other direction next to it. Okay, so that should be our answer. And again, the final step is always about the total area, removing the ones that are not included, so we are left with ones that we're interested in. So that's how to do a problem like this. And before we move on to our third problem of today's live stream session, there's a quick information session provided to you guys. So I know a lot of you guys who are watching this live stream video right now are preparing for the upcoming 2025 AMC examination. Okay, so we're offering a dozen of short-term classes to help you kids get better prepared. Starting in July, we are actually offering a real exam practice lesson. So for that lesson, the teacher will help students to go through exam problems from past year's AMCA. So all of the problems included in this class are real exam problems. Okay, so it's really been beneficial for students who are looking to get a better understanding about what problems they are likely to encounter in the exam and what styles of problem that they should be mastered. So this is a class, although it's been 2 classes passed, however, each of these classes, they are not connected with each other because all of the classes are focused on past year's exam. For example, maybe class 1 is about 2011, AMC8, and class 2 is about 2017, and class 3 is about 2019. So you can see these classes, it doesn't matter if you take the first 2 so that you can take the second. You can directly jump into the second class, okay? And also we'll include the latest AMC8 exam in the last class. So as in August and September, we'll start our first round of AR and HR class. So what is an AR class? AR class is a class that is designed specifically for those who are aiming for the achievement role in the upcoming AMCA. And HR class is basically off the same deal. However, it will be more challenging because in HR class, students are looking for achieve the HR, which is honor roll prize. So it will be focused more on the last 10 problems, okay? And we will have our AMCA mock test. So in the mock test, we'll give the student exactly same circumstance as they will encounter in the real test, which is 25 multiple choice, time restriction of 40 minutes. And after the test, there will be an information session to go over the hardest 10 problems covered in the exam, and also a quick 10 minutes information session about how to get prepared for the AMC. Okay, so that's basically the same for October and November. And we'll have our third round of AR and HHR class in December. Also another round of AMC8 mock test. So as we step into January, we are so close to actually taking the test. So we'll offer the final round of AMC mock test to make sure everybody is onto the test with great confidence. And also there will be a short-term DHR class. DHR class is basically a class designed for students who are aiming for the distinguished honor roll. So this class are supposed to be challenging because it will focus on the last 3 problems. For example, problem number 22 to 25. Okay, So you can see there are more than 10 classes offered and 5 rounds of mock tests. And the suggestion is, please take those classes that you feel will be most beneficial for your students. For example, if you are looking for the achievement role, then it's recommended you take the 3 round of achievement role classes and maybe take 2 of the mock tests, and you can add 1 of the real exam practice class. Okay, so that should be very enough. The purpose is not to take every single of these classes. It's about to take those that are a good fit for your schedule and for your current level. Again, if you have any question about which class to select and which class to attend, you are very welcome to add me on my WeChat. My working WeChat ID is ThinkVIP60. T is capitalized, VIP is capitalized, and there is no space in between. Additional to that, we are also having a very valuable Facebook group that is going to share some valuable materials that you can use for study to the exam. Also, we're going to exchange some important information about what exam is going to look like. Okay, so you can search on Facebook titled AMC8 Helpful and Educational Math Resources. Again, this is a very good group for you to not only get problems, get solutions, but also to get experiences about how to prepare for the AMCA from current parents and others who may take the AMCA multiple times. Okay, so these are for the information session. I can pause for 10 seconds. So in case you want to take a screenshot or take a picture. Okay. All right, cool. So let's go back to our problem solving part. And now we are on to exercise 9, warm up. The question says the surface of a 4 times 4 times 4 cube is painted red, which is shown exactly in the figure. Sorry. And then the cube is cut into 64 small cubes of the same size as shown below. The question is, how many small cubes have 0 faces that are painted red? Okay, so as our experiences, we use the technique in the past problem, we know that talking about cubes that have 0 faces is basically asking for those that are put exactly in the middle of the big cube, right? So first, let me highlight the question. How many small cubes have 0 faces? Okay, the keyword here is 0. Now, let's try to think about if I take these 4 cubes as our middle column, right? We should be able to find all of those cubes with 0 faces. So how can we achieve that? Okay, let me draw another figure right next to it, only about this middle column. Okay, I zoom out too much. Good. So, okay. You see, when you are working on some geometry problem, it's always about drawing, okay? So do not hesitate to draw some helping lines and some figures on your notes, which will be extremely helpful for your understanding, okay? All right, this should be 1, 2, 3, 4, 4 layers. So I'm going to do the exact same on my own copy of the figure. So it should look like something this way, okay? Okay, good. So this is actually the middle columns, which are composed of 2 rows, and each row has 2 cubes. Okay, each row has 8 cubes. In this case, on the top 4 cubes, these faces. So let me use red. Okay, these faces are going to show off and paint it red, right? And in the bottom, there's also 4 cubes, which is going to have their bottom faces showing off painted in red. So it looks like we are only interested in the middle 4 cubes, right? So the first layer is 4, the second layer is also 4. In this case, we can just add them up, right? So if you number them, there is 1, there is 2, okay? And you see on the other side, there should be a 3, and this is 4. Same deal for the ones that are 1 layer entering. There's our first one, second one, okay? So this is also our second one. So this is our third one on the other side, and this is our fourth one. So if you add these together, we should have 4 plus 4 equals 8, okay? You can see we are choosing option A, and the calculation itself is actually quite simple and straightforward. However, the difficult part is, how do you know that it's in the middle column? That is, when we want to talk about cubes that have 0 faces showing to the audience to the outside, always think about the middle ones. Because the middle ones, they are likely to have other cubes in front of it, behind it, to the left of it, or to the right of it, okay? So this is the place where we want to look for zero faces cube, okay? So that's for this problem. Again, if you just think about the entire figure into one unit, it can be too much and too complicated, a lot of room for making mistakes. However, if you only draw the important part outside separately, it should be rather clear, okay? So that's for our exercise 9 warm-up. Now, we are ready to see a problem that is of the same technique, but from a real AMC exam. Actually, it's quite close. It's 2020 AMC 8, problem number 9. A Koch birthday cake is in the form of a 4 times 4 times 4 inch cube. The cake has icing on the top and four side faces. So let me highlight the keyword for you guys. The cake has icing on the top and the four side faces, okay? Which means there are no icing on the bottom. Okay, so this is actually of great importance because when counting about face that with icing, we cannot count those bottoms. So suppose the cake is cut into 64 smaller cubes, each measuring 1 times 1 times 1 as the dimension, as shown below. How many of the small pieces will have icing on exactly 2 sides? Okay, think about it. So we can now try to still use our old technique, that is break down the entire solid figure into layers. Okay, so I will say, let me change my pen to a different color. This is our first layer. This is our second layer. This is the third layer, and this is the fourth and last layer. Again, by cutting the solid figure into layers, it's not limited to only cut it horizontally, okay? If it's more helpful, you can definitely cut it vertically. So in this case, it's helpful to cut it horizontally. Let me go back to color blue. So take a look of these cubes. These cubes have other cubes next to it and behind it and under it. However, on the left-hand side and on the top of this cube, there are no other cubes. So there are two faces facing to the audience, facing outside, right? Showing with icing. This case, these two cubes counted. And similarly, you can use symmetry to find there's another two cube, right? Also, so that is in the in one direction. There's another way to find it in the cross direction, right? It's about the same case because you can see these two cubes. They also have two faces facing outside, which means they are covered in eyes, right? Next to these cubes, there are other cubes. So block two faces, and behind this cube, there are cubes, under it, there are cubes. So only two faces are left facing outside with icing. And again, using symmetry, there is the other pair of cubes, right? So that is how many? Already 8 cubes, okay? Now think about, as I said, we are cutting this solid figure into layers. Now we are good with the first layer. So just from the first layer, we are having 8 cubes that has exactly how many? 2 faces on icing, okay? So this is our main interest, have icing on exactly 2 faces. Good. So let me write down on the first layer, we are having 8 such cubes. Now, after done with the first layer, we can definitely move on to our second layer. So let me make my handwriting better, okay? So that's for the first layer. Good. So on the second layer, how about the second layer? The second layer, it has a different case, right? Because the second layer, only these two that are on the edges have 2 faces showing off. Why? Because think about these two cubes, originally they have 6 faces. So the maximum faces coming with the eyes is 6. However, above it, under it, 2 faces are gone because there are other cubes. To the left and to the behind it, there are also 2 cubes. So that's in total 4 faces being blocked by other cubes. So 6 minus 4 is 2. That is exactly 2 sides having icing on it. So by symmetry, you should find there's another one on this column, this edge, and one behind it, right? So that should be 4. And this should be the exact same case as our third layer, right? Third row. Why? Because same deal, right? Consider about the 6 faces. 4 of them are blocked by other cubes. So 6 minus 4, we are left with 2. That satisfies the restriction of 2 faces with icing. So for the second and third layer, we can consider into one case, right? Let's classify them into one case. So let me change my color. For the second and the third layer, okay? There are how many? 4, right? So since it's 2 layers, each one has 4. So it should be 4 times 2. Okay, very good. Now we're on to our fourth and last layer. So I will say fourth layer. Okay, so let me write my handwriting a little bit better, okay? Fourth layer. Okay, good. Now, for the first layer, there's one very important condition that we can use. That is, there are no icing on the bottom. So, given this condition to be true, we are going to have this one on the corner, this one on the corner, and this one on the corner, okay? These to be what? Exactly 2 faces with icing. Why? Because originally on the corners, it has 3 faces facing outside. However, the bottom face does not count, right? Bottom doesn't have icing on it. So 3 minus 1, excluding the bottom face, we only have 2, right? So that is how many? 4 corners, so 4 cubes. So let me get my pen in green again. So that is 4. And our final job is always easy, right? Just add them up. So we break down the solid figure into 4 layers, and we count the number of cubes satisfy the condition for each layer. The last step is to add up the number from each layer. So that is 8. So let me write down total. Okay, let me write it better. So the total should be, okay, let me zoom in a little bit. I zoom out too much. Okay, good. The total in this case is just 8 for the first layer, plus 2 times 4 for the second and third layer, plus another 4. That is 16 plus 4, which is 20, okay? So let's put a little box to denote the final answer. We know there are exactly 20 faces, 20 cubes that has 2 faces covered in ice, okay? So that's for this problem. Again, same technique, counted by layer, then add them up. Now, before we move on to the last 2 problems of today's live stream session, it's kind of important that I give an information session, okay? So, as I know a lot of my audience now, you guys are preparing for the upcoming 2025 AMC exam. So, we are offering some classes to get you, help you better prepare. Starting in July, we will have our first round of AMC mock test, which already passed. However, you can still access the link and get to know the live stream answer explanation session by playback, okay? And we will have our second round of real exam practice class. So this class is going to be beneficial for those who are looking for a better understanding of what kind of problem they are likely to encounter in the AMC exam, and to practice their time management in real exam, and maybe try to make sure they get to understand the style of problems that are very important in the real exam. So these classes will cover past exam problems from each year, for example, 2018, 2019, and also the most recent 2024, okay? So after that, as we step into August or September, there will be short-term AR and HR class. By its name, AR class are designed specifically for those who are aiming for the AR prize. That is the achievement role. And HR class is designed specifically for those who are aiming for the HR prize or honor roll. So HR class and AR class are about the same format, same style, but HR class are supposed to be a little bit more challenging than AR class because it will focus more on the later part of the exam. That is basically from problem 18 to 22. Okay, about the AR level, HR level. And it's the same deal for the AMC mock test. There will be a mock test exactly like the same one you are going to see in the January real test, 25 multiple choice questions, and 40 minutes time restriction. And there will be a live stream directly. There will be a live stream about a problem explanation directly after mock test, and also some information session about how to get better prepared for the exam. Okay, so same deal for October and November, and in December, we'll have our last and final round of AR and HR class. So in total, there are 3 rounds of short-term AR HR class and 1 more round of AMCA mock test. As we are ready to step into the exam in January, mid-January, before that, we're going to have our first short-term DHR class, which will only be which will be the only DHR class as well. So DHR class is designed for those who are aiming for the Distinguished Honor Roll Prize. Okay, so it's supposed to be hard and supposed to be challenging, as the class will be focused on the last 3 problems. So basically from 22 to 25, so that's 4 problems actually, and we'll have our final round of AMC8 mock test. Okay, so as you can see, there are dozens of classes offered and 5 rounds of mock tests. It's a lot, so it's highly recommended that you take the class you need based on which will be the best one to beneficial your score on AMCA. So that is, you are very welcome to add me on WeChat. So my WeChat working ID is thinkvip60. T capitalized and VIP capitalized. So after you add me on WeChat, I will try my best to help you figure out which is the class that is about the right level for you, which will be the class that maybe you can take it later, and maybe give you a recommended timeline for which mock test to schedule. Okay, so that's for my WeChat ID. And also additional to that, there will be very good resources for preparing for AMC8 located in the Facebook. Okay, so you can search on the name AMC8 helpful and educational math resources on Facebook group. So as you enter this group, you will not only see some valuable resources, valuable problem sets you can work to get prepared for the exam, but also there will be exchange of information. There will be experience sharing about how others prepare for the exam in the past years. So highly recommend it. You search this name, you take a screenshot of this page, so that you can get all the information you need. Okay, so I will pause here for 10 seconds. Okay, very good. Now we are on to the last 2 problems of today's live stream session. So for the exit ticket, the surface of a solid figure is painted green, and then the solid figure is cut into 12 small cubes of the same size as shown in the figure below. The question is, how many small cubes have 3 faces that are painted green? So let me get my pen. I'll use yellow, okay, for better distinguishment. So still, let's count it by layer. This time, I still want to do horizontal layer, cut it horizontally. So this will be our first layer. Okay, this color doesn't look too good on the graph. Let me change to maybe purple, okay? So as I said, let's cut it horizontally. This is all be our first layer, and this is going to be a second layer, and of the same deal, this is our third layer, okay? Again, these number 1, 2, 3, they are the order of the layer. Now, the question is, how many cubes have 3 faces? We want to consider the bilayer. So in the first layer, okay, let me write a little bit better, okay. So in the first layer, we have 2 cubes, and among those 6 faces, one of the faces is blocked because there are cubes under them, and one of the faces is blocked because there are cubes next to it. So that's 2 out of the 6 faces being blocked, and 6 minus 2 is 4. But we are looking for cubes with 3 faces. So 4 is not equal to 3. Definitely these 2 doesn't count. So on the first layer, we have nothing, right? We have 0 cubes satisfy the given condition. Now, as we move to our second layer, how many cubes satisfy the condition? This should be 2, right? Which 2? So let me change my color into yellow this time. These are the cubes. Okay, next to it, there's another one. These are the cubes that have exactly 3 layers. Why? Among the 6 layers, one of the cube is next to it, so 1 layer is gone. One of the cube is behind it, so 1 layer is gone. One of the cube is under it, so 3 faces are blocked by other cubes. That is, 6 minus 3 leave you a difference of 3, right? So 3 layers, 3 faces painted with green. That will satisfy the condition. So the answer here should be 2, right? For the second layer only. Okay, let me use a different color. All right, so about the last and final layer, our third layer, let's see how many cubes satisfy the condition. So I will say third layer. Okay, so for our third layer, let me shift my screen a little bit and use yellow one more time. So this should be exactly 2, right? This one and the one next to it. So there is 2. There's also 2. Why? Because let's consider about these two. These two doesn't count, right? Because how many? 4 faces are facing out. Notice in this problem, the condition says in a very clear manner, that is, the surface of a solid figure is painted green. So the surface include what? All the faces facing to the audience, which definitely counts the bottom face. So you can remember, I think in the last 2 problems, we talked about one of them is about the bottom doesn't count, right? All the other faces are with icing, but the bottom doesn't have. However, this is a different case because entire surface area painted with green. So the bottom face definitely count in this one. So let me make a quick note here. I will say the bottom. Okay, let me write it better. Bottom is also painted green. So we should count it. Okay, very good. So if you count the bottom, the 2 cubes on the right-hand side doesn't count, right? They all have 4 faces facing out. So we are only including the ones on the left. Same deal as what we made about the second layer. So there's 2. Because there are cubes on top of it, there are cubes next to it, there are cubes behind it. So 6 minus 3, we have 3 faces that are facing outside, which are painted green. Now we can just do the simple step, that is, add these numbers together layer by layer. Okay, let me write it better. That is 0 for the first layer, plus 2 for the second layer, and 2 for the third layer, which is 4. So that's why we choose B. Okay, for this problem, we want to be careful if the bottom face count or not. If it counts, it means we have additional 2 layers. If it doesn't count, we'll have 4 for the third layer. Okay, so that's for this second to the last problem. And now for the last problem, so this is a problem that I manually added to today's live stream. It's not included in the book. So if you didn't see in the book, that's totally fine because it's supposed to be not in the book. Okay, it's a problem I manually added. I think it's a good exercise for you guys to work on. A rectangular octahedron has 8 equilateral triangle faces with 4 faces meeting at each vertex. So this is about how this figure is composed, which is good. So our character Jun will make the regular octahedron show on the right by folding the piece of paper shown on the left. Okay, so that this problem is about an extended view about the nets of a solid figure. The question is, which number of faces will be end up to the right of Q? Okay, so let me shift it back. Okay, good. So my pen. Which will be the faces to the right and right of Q? So this problem, while you're working on with extended view problem or a nest problem, one of the worst situation you can do is to count it in your head. That will be very, very easy to get to a mistake. So what is a better way to do it? A better way to do it is to mark each of the vertex, okay? Assign a letter to each of the vertex so you know how to do it. In this case, let's assign the vertex of the face next to Q on the right-hand side to be ACD. So I will call these vertex to be A, these vertex to be C, these vertex to be D. Okay, so now the question becomes, among 1, 2, 3, 4, 5, 6, 7, these 7 faces, which of it is corresponded to the triangle ACD, right? So we want to do the same thing and mark all the other vertex, but I will use a different color for distinguishment. So let's say this vertex B, the one behind the figure is E, and the one on the very bottom is F, okay? So if you count it, there should be how many? A, B, C, D, E, F, right? 6. Okay, so there should be 6 vertices. And let's try to find out which vertex is which letter onto the expanded view. So for Q, we have Q marked. We know on top of Q is A. So I will say this is our vertex A. On the left-hand side, on the lower left corner of the triangle Q, there's B. And on the lower right corner, we do have C. Okay? Now, think about, instead of looking to the right-hand side, think about to the left-hand side. Because each triangle has 3 vertices. If we have 2 out of the 3 vertices determined, it's easier to determine for the last one than to start with a triangle with 0 vertex determined, right? Now, for our triangle marked with number 6, among those 3 vertices, 2 of them are determined as A and B. So naturally, if you take a look of our original solid figure, we'll know the vertex on the top left corner should be our vertex E, right? Now, we have 2 triangles with each have 2 vertex determined. That is triangle number 5 and triangle number 7. So for number 7, if you see AE is done, if you take a look of the solid figure, the only phase that composed of AE are AEB and AED. And we already have AEB marked. So by using the method of elimination, we'll know the top vertex of triangle 7 is D. Okay, so we are done with triangle 7. Now, back to another triangle that has 2 out of the 3 vertex figured out. That is triangle number 5. So for BE, if BE is 2 out of the 3 vertices, the only 2 triangles is BEA and BEF. And BEA, again, is already marked in our figure. So again, by the method of elimination, we know the lower left corner of triangle number 5 must be BEF. Okay, BEF. Now, on to our figure. Triangle number 4, 3 vertices, among them, 2 of them are determined. That is E and F. So for E and F, think about E and F is connected with point D, right? You can have EFB and EFD to be the only triangle that involves E and F. EFB is already marked on our figure. So our third term use of elimination method, we get point D. Notice that our goal, sorry, I zoom out too much. Okay, so our goal is to find the triangle ACD. Now we have D already marked on our figure, which means we are really close to the final answer. Okay, so let me zoom in a little bit. Okay, why it doesn't allow me to zoom in? Okay, good. So this is our point D. Again, take a look. Now among the triangles 3 of the vertices, 2 of them are known, which is D and F. So for D and F, the 2 triangles we have are, let me see, DFE, which is already marked, and what? DFC, right? So by a method of elimination, DF must be paired up with C. So this is our point C. Now, think about triangle number 2. Number 2, we have CF already determined. So for CF, we have CFD as one of the possible triangle, and also CFB, right? So CFB is not being used yet. So we know the vertex on the bottom of triangle 2 must have the last vertex to be point B. So since B is not of our interest, I will just use the blue color. Again, green colors are for those vertices that we are interested in, and blue colors are for those that we are not interested in. Okay, so finally, our last step, we are looking for triangle ACD. So CD, this line segment is marked on the figure. CDF, which is phase number 3, is already used. So our one and last time usage of elimination method, we know triangle number 1 must have its 3 vertex to be A, C, and D. Okay, so our last vertex on the very left-hand side of our figure, expanded view, must be vertex A. So which of the triangle will end up to the right of Q? That is ACD. And what is the number corresponding to triangle ACD? 1. Okay, so that's why we choose option A. Again, when you are asking for the expanded view of a solid figure, try not to think about in your mind. Okay, try to give each vertex, each line segment a name, then mark those vertex and line segment onto expanded view, so it's easier for you to stay not getting lost, and it has a far less room of making mistakes. So that's for this problem. I hope all of you guys get how to solve it. And before we finish today's live stream, there's gonna be one last information session. So I know a lot of you guys who are watching this live stream video right now are preparing for the upcoming 2025 AMCA. So as Think Academy, we are offering a number of classes which can help you study for the exam. So starting in July, we will have our first round of AMCA mock tests, which already been passed, but you can still get the link of the exam and also watch the playback for teachers' detailed explanation of the last, I think, 15 problems, okay? And beside that, we will have a class titled Real Exam Practice, or titled, there's another name for that, that is Prepare Study AMCA from Prepare last year's exam. So in this class, the teacher will help the student to go through exam problems from last year's and the years before that. So for example, the first class may be focused on 2011, and the second class will focus on the AMCA exam on 2014. So it's guaranteed that every single problem covered in content of the lessons are from real exam problem, or from real AMCA exam. So these classes are really good for those who want to know the format and style of problems that they are likely going to see on the exam. Besides that, as we step into August and September, there will be our first round of AR and HR class. So AR class is the abbreviation for those who are aiming for the AR prize achievement role, and same deal for the HR. So the major difference between these two classes is that the material covered in the HR class will focus more on the later part of the exam. That is from problem number 17 to problem number about 22, okay? So that's supposed to be more challenging for HR class than the AR class. And there will be another round of AMC mock test. Again, the test will be the exact same format as the one you see in the mid-January. So that's still 25 multiple choice, 40 minutes time restriction. Okay, so as we finish as we finish August and September, step into October and November, we'll have our second round of AR and HR class, another round of ANC mock test, about the same deal. So I will not going to elaborate on this. And on to December, we'll have our final round of AR and HR class, and one more round of AMCA mock test. So before we actually step into the room for taking the test in mid-January, there will be the one of only round of DHR class. So the DHR class, purpose of that is designed specifically for those who are aiming for the distinguished honor roll. So it's supposed to be challenging, as the teacher will spend most of the time in the class talking about question number from 20 to 25, okay? And before the exam, we'll have our final AMCA mock. So we are making sure that everyone will going to step into the exam room with a great confidence and well prepared. And for your information, you can also add me on WeChat. My working WeChat ID is thinkvip60 with T capitalized, VIP capitalized, and no space in between. The purpose for adding me on WeChat is that for any time you have a question about which class to take and which timeline to keep follow, you can text me and I will try to respond to you as soon as possible. So this is also going to talk about what are the classes that are going to fit your purpose the best, right? So there are a dozen of classes. It's not likely you're going to take all of them one by one. So for example, if you're aiming for the AR prize, how about let's just take the 3 rounds of AR class, maybe add it with 2 rounds of mock test, and the AMCA prepare with past exam lesson. So that should be very enough. That's just for example, okay? And another thing I do want to mention before I close today's live stream is for the Facebook users, okay? We are going to have a very good resource group sharing those problems you can study for the exam, and also exchanging information about the style of the problems and preparing for exam experiences. The group name is called AMCA Helpful and Educational Math Resources. Again, if you enter this group, you will not only see problem sets, we will not only see a solution and answer keys for those problem sets, there will be also videos and also people sharing their experiences when they were preparing for the last year's or past year's AMCA exam. Okay, so again, thank you so much for coming to today's live stream, and we'll have the exact same time for next week. That is Thursday from 4 p.m. to 5 p.m. On the Pacific Daylight Time, holding another live stream. And I think in the next week's AMCA live stream, we'll talk about questions from the statistic and probability module. Okay, now I would like to thank you again, and please have a good rest of your day. I will see you guys next time. Bye.